An electron of mass m and a photon have same energy E. Electron, the mass m, and the photon have same energy E. That means energy is the same. The ratio of de Broglie wavelengths associated with them is, here the c being a velocity of light. C, it is the constant velocity we need to take here. There is the velocity of the light. Okay. Then which of the following option is correct? We need to find here. For electron with energy E, its de Broglie wavelength is given by, that is, lambda E is equal to h divided by p, and if we are going to write the p value as h divided by under root of 2me. Then for a photon with the same energy E is, that is E is equal to, we can write it as h times v, and we can write it as hc divided by lambda p. Then this leads to the lambda p is equal to hc divided by E. Then to find the ratio of electrons de Broglie wavelength to a photon's wavelength is, that is, lambda E divided by lambda p is equal to h divided by under root of 2me into E divided by hc, because this is reciprocal. Then we get the value 1 divided by c, this is the constant, and h will get cancelled. Then in the numerator E terms as it is, and in the denominator term, that is a 2m is there under root of 2m. This is the final equation. So we can see this equation 1 by c, it is there here. E divided by 2 means 2m to the power of 1 by 2. Then option A is the right answer. This we can write it as 1 by c into e to the e by 2m to the power of 1 by 2.